Olá! Desde que o primeiro telescópio foi fabricado há mais de 4 séculos, não passou um ano sem que o homem tenha feito alguma nova descoberta sobre o universo. Imagine a quantidade de dados apurados ao longo desses 400 anos. O que mais surpreende os cientistas é que, embora eles venham juntando informações sobre o sistema solar e os planetas nesse tempo todo, ainda sabem muito pouco. Há um mundo novo a ser explorado. Nesta edição do Matéria de Capa, vamos dar uma pequena ideia dessa imensa tarefa. Fique com a gente. Galileo Galilei pode não ter sido o inventor do telescópio, mas foi o primeiro a fazer grandes descobertas desde a noite em que apontou o seu telescópio feito em casa para os céus.
For millennia, mankind gazed out into the mesmerizing night sky, without recognizing the stars of our own Milky Way galaxy as other suns, or the billions of sister galaxies making up the rest of our universe. Or that we are merely punctuation in the universe's 13.7 billion year-long story. With only our eyes as observing tools, we had no means of finding solar systems around other stars, or of determining whether life exists elsewhere in the universe.
Today, we are well on our way to unraveling many of the mysteries of the universe, living in what may be the most remarkable age of astronomical discovery. I'm Dr. J, and I will be your guide to the telescope, that amazing instrument that proved to be mankind's gateway to the universe.
4 centuries ago, in 1609, a man walked out into the fields near his home. He pointed his homemade telescope at the moon, the planets, and the stars. His name was Galileo Galilei. Astronomy would never be the same again. Today, 400 years after Galileo first pointed a telescope to the skies, astronomers use giant mirrors on remote mountaintops to survey the heavens. The telescopes collect faint chirps and whispers from outer space. Scientists have even launched telescopes into Earth orbit, high above the disturbing effects of our atmosphere. And the view has been breathtaking.
However, Galileo did not in fact invent the telescope. That credit goes to Hans Lippershey, a slightly obscure Dutch-German spectacle maker. But Hans Lippershey never used this telescope to look at the stars. Instead, he thought his new invention would mainly benefit seafarers and soldiers. Lippershey came from Middelburg, then a large trading city in the fledgling Dutch Republic. In 1608, Lippershey found that when viewing a distant object through a convex and a concave lens, the object would be magnified if the two lenses were placed at just the right distance from one another. The telescope was born. In September 1608, Lippershey revealed his new invention to Prince Maurits of the Netherlands. He could not have chosen a more advantageous moment, because at that time, the Netherlands were embroiled in the 80 Years' War with Spain. The new spyglass could magnify objects, and so it could reveal enemy ships and troops that were too distant to be seen by the unaided eye. A very useful invention indeed.
Italian astronomer Galileo Galilei, the father of modern physics, heard about the telescope and decided to build his own. Galileo was the greatest scientist of his time. He was also a strong supporter of the New World view advocated by the Polish astronomer Nicholas Copernicus, who proposed that the Earth orbited the Sun instead of the other way round. Based on what he had heard of the Dutch telescope, Galileo constructed his own instruments. They were of much better quality. It was time to train the telescope on the heavens.
I have been led to the opinion and conviction that the surface of the moon is not smooth, uniform, and precisely spherical, as a great number of philosophers believe it to be, but is uneven, rough, and full of cavities and prominences, being not unlike the face of the earth.
A landscape of craters, mountains, and valleys. A world like our own. A few weeks later, in January 1610, Galileo looked at Jupiter. Close to the planet, he saw 4 pricks of light that changed their position on the sky night after night along with Jupiter. It was like a slow cosmic ballet of satellites orbiting the planet. These 4 pricks of light would come to be known as the Galilean moons of Jupiter. What else did Galileo discover? The phases of Venus. Just like the moon, Venus waxes and wanes from crescent to full and back again. Strange appendages on either side of Saturn. Dark spots on the face of the sun. And, of course, stars. Thousands of them, maybe even millions, each too faint to be seen by the naked eye. It was as if mankind had suddenly thrown off its blindfold. There was a whole universe to discover out there.
Com a invenção do telescópio, utilizado a princípio mais com fins militares do que científicos, houve uma corrida na Europa pelo aperfeiçoamento do aparelho.
News about the telescope spread across Europe like wildfire. In Prague, at the court of Emperor Rudolf II, Johannes Kepler improved the design of the instrument. But the best instruments of the time were probably constructed by Christian Huygens in the Netherlands. In 1655, Huygens discovered Titan, the largest moon of Saturn. A few years later, his observations revealed Saturn's ring system, something Galileo had never understood. And last but not least, Huygens saw dark markings and bright polar caps on Mars. Could there be life on this remote alien world? The question occupies astronomers to this day.
Ao mirar o espaço infinito, os cientistas acabam descobrindo dados que contribuem para a compreensão das origens do universo. É como olhar num retrovisor com alcance de bilhões de anos atrás.
A little less than 14 billion years ago, the universe was born in a huge explosion of time and space, matter and energy called the Big Bang. Tiny quantum ripples grew into dense patches in the primordial brew. From these, galaxies condensed, a stunning variety of sizes and shapes. Nuclear fusion in the cores of stars produced new atoms: carbon, oxygen, iron, gold. Supernova explosions blew these heavy elements back into space, raw material for the formation of new stars and planets. Someday, somewhere, somehow, simple organic molecules evolved into living organisms. Life is one miracle in an ever-evolving universe. We are stardust. It's a grand vision and a sweeping story, brought to us through telescopic observations. Imagine, without the telescope, we would know about just 6 planets, 1 moon, and a few thousand stars. Astronomy would still be in its infancy.
Like buried treasures, the outposts of the universe have beckoned to the adventurous from immemorial times.
George Ellery Hale had one final dream: to build a telescope twice as large as the previous record holder. Meet the grand old lady of 20th century astronomy, the 5-meter Hale telescope at Palomar Mountain. Over 500 tons of moving weight, yet so precisely balanced that it moves as gracefully as a ballerina. Its 40-ton mirror reveals stars 40 million times fainter than the eye can see. Completed in 1948, the Hale telescope gave us unsurpassed views of planets, star clusters, nebulae, and galaxies. Giant Jupiter, with its many moons. The stunning Flame Nebula. Faint wisps of gas in the Orion Nebula.
Daqui a pouco, das montanhas do Havaí aos desertos do Chile e do Arizona, gigantescas antenas vasculham o espaço. E mais, a radiação infravermelha mostra o que o homem tem em comum com os corpos celestes. A gente volta já. Do arquipélago do Havaí aos desertos do Chile e do Arizona, nos Estados Unidos, olhos gigantes observam o espaço. Do ponto mais seco da Terra, os cientistas apontam a maior máquina astronômica para os céus.
Mauna Kea Observatory sits on the highest point in the Pacific, 4,200 meters above sea level. On the beaches of Hawaii, tourists enjoy the sun and the surf. But high above them, astronomers face chilling temperatures and altitude sickness in their quest to unravel the mysteries of the universe. The Keck telescopes are among the largest in the world. What will be tonight's catch? A pair of colliding galaxies billions of light years away? A dying star gasping its last breath into a planetary nebula? Or maybe an extrasolar planet that might harbor life? On Cerro Paranal in the Chilean Atacama Desert, the driest place on Earth, we find by far the biggest astronomy machine ever built, the European Very Large Telescope. The VLT is really 4 telescopes in one. The huge mirrors were cast in Germany, polished in France, shipped to Chile, and then slowly transported across the desert. At sunset, the telescope enclosures open up. Starlight rains down on the VLT mirrors. New discoveries are made.
A laser pierces the night sky. It projects an artificial star into the atmosphere 90 kilometers above our heads.
Other big telescopes can be found all over the globe. Subaru and Gemini North on Mauna Kea, Gemini South and the Magellan telescopes in Chile, the Large Binocular Telescope in Arizona. They are constructed at the best available sites, high and dry, clear and dark. Here's what they've shown us. Planets. Nebulae. The actual sizes and squash shapes of some stars. A cool planet orbiting a brown dwarf. And giant stars whirling around the core of our Milky Way galaxy, governed by the gravity of a supermassive black hole. We've come quite a way since Galileo's day.
Ao longo do tempo, o telescópio passou por inúmeros aperfeiçoamentos, mas poucos foram tão revolucionários como a entrada na era digital.
400 years ago, when Galileo Galilei wanted to show others what he saw through his telescope, he had to make drawings. The pockmarked face of the moon, the dance of the Jovian satellites, sunspots, or the stars in Orion. He took his drawings and published them in a small book, The Starry Messenger. That was the only way he could share his discoveries with others. For well over 2 centuries, astronomers also had to be artists. Peering through their eyepieces, they made detailed drawings of what they saw. The stark landscape of the moon, a storm in the atmosphere of Jupiter, the subtle veil of gas in a distant nebulae. And sometimes they overinterpreted what they saw. Dark linear features on the surface of Mars were thought to be canals, suggesting civilized life on the surface of the red planet. We now know that the canals were an optical illusion. What astronomers really needed was an objective way to record the light collected by their telescopes, without the information first having to pass through their brains and their drawing pens. Photography came to the rescue. When you take in the night sky with your own eyes, once they're dark adapted, you don't see more and more stars just by looking longer. But with a photographic plate, you can do just that. You can collect and add up the light over hours on end. So a longer exposure reveals more and more stars. And more, and more, and then some. In the 1950s, the Schmidt telescope at the Palomar Observatory was used to photograph the entire northern sky. Almost 2,000 photographic plates, each exposed for nearly an hour. A treasure trove of discovery. Photography had turned observational astronomy into a true science. Objective, measurable, and reproducible. But silver was slow. You had to be patient.
The digital revolution changed all that. Silicon replaced silver, pixels replaced grains. Even in consumer cameras, we no longer use photographic film. Instead, images are recorded on a light-sensitive chip. Robotic telescopes equipped with sensitive electronic detectors are keeping watch over the sky right now. The Sloan telescope in New Mexico has photographed and catalogued over 100 million celestial objects, measured distances to 1 million galaxies, and discovered 100,000 new quasars. But one survey is not enough. The universe is an ever-changing place. Icy comets come and go, leaving scattered debris in their wake. Asteroids zip by. Distant planets orbit their mother stars, temporarily blocking part of the star's light. Supernovas explode, while elsewhere new stars are born. Pulsars flash, gamma-ray bursts detonate. Black holes accrete. To keep track of these grand plays of nature, astronomers want to carry out all-sky surveys every year, or every month, or twice a week. At least that's the ambitious goal of the Large Synoptic Survey Telescope. If completed in 2015, its 3-gigapixel camera will open up a webcam window on the universe. More than fulfilling astronomers' dreams, this reflecting telescope will photograph almost the entire sky every 3 nights.
Imagine que muitos corpos do espaço brilham numa faixa de visão que não conseguimos enxergar. É exatamente isso que acontece. São frequências luminosas que agem como ondas de rádio.
When you listen to your favorite piece of music, your ears pick up on a very wide range of frequencies, from the deepest rumblings of the bass to the very highest pitched vibrations. Now imagine your ears were only sensitive to a very limited range of frequencies. You'd miss out on most of the good stuff. But that's essentially the situations that astronomers are in. Our eyes are only sensitive to a very narrow range of light frequencies, visible light, but we are completely blind to all other forms of electromagnetic radiation. However, there are many objects in the universe that do emit radiation at other parts of the electromagnetic spectrum. For a start, our sun shines very brightly at radio wavelengths. So does the center of our Milky Way galaxy. But there's more. Pulsars are very dense stellar corpses that emit radio waves only into a very narrow beam. In addition, they rotate at speeds of up to several hundred revolutions per second. So in effect, a pulsar looks like a rotating radio lighthouse. And what we see from them is a very regular and fast sequence of very short radio pulsars, hence the name. Many objects in the universe also glow in the infrared. Discovered by William Herschel, infrared radiation is often also called heat radiation, because it is emitted by all relatively warm objects, including humans. You may be more familiar with infrared radiation than you think, because on Earth, this kind of radiation is used by night vision goggles and cameras. But to detect the faint infrared glow from distant objects, astronomers need very sensitive detectors, cool down to just a few degrees above absolute zero in order to suppress their own heat radiation. Today, most big optical telescopes are also equipped with infrared cameras. They allow you to see right through a cosmic dust cloud, revealing the newborn stars inside, something that just cannot be seen in the optical. For example, take this optical image of the famous stellar nursery in Orion. But look how different it is when seen through the eyes of an infrared camera. Being able to see in the infrared is also very helpful when studying the most distant galaxies.
With a stunning variety of instruments, astronomers have opened up the full spectrum of electromagnetic radiation and have even ventured beyond. But some observations simply can't be done from the ground. The answer? Space telescopes.
Em instantes, o telescópio Hubble revoluciona a maneira de ver o universo, mas os cientistas não estão satisfeitos e vão lançar em breve a máquina mais sofisticada, já imaginada até hoje, para varrer os pontos mais distantes do sistema solar. A gente volta já. Com suas lentes poderosas, o telescópio Hubble transformou a maneira de ver o universo e revolucionou a astronomia.
The Hubble Space Telescope. It is by far the most famous telescope in history. And for good reason. Hubble has revolutionized so many fields in astronomy. By modern standards, Hubble's mirror is actually quite small. It only measures about 2.4 meters across. But its location is literally out of this world. High above the blurring effects of the atmosphere, it has an exceptionally sharp view of the universe. And what's more, Hubble can see ultraviolet and near-infrared light. This light just cannot be seen by ground-based telescopes because it is blocked by the atmosphere. Cameras and spectrographs, some as big as a telephone booth, dissect and register the light from distant cosmic shores. Just like any ground-based telescope, Hubble is upgraded from time to time. Spacewalking astronauts carry out servicing missions. Broken parts get refurbished, and older instruments get replaced with newer and state-of-the-art technology. Hubble has become the powerhouse of observational astronomy, and it has transformed our understanding of the cosmos.
With its keen eyesight, Hubble observed seasonal changes on Mars, a cometary impact on Jupiter, an edge-on view of Saturn's rings, and even the surface of tiny Pluto. It revealed the life cycle of stars, from their very birth and baby days in the nursery of dust-laden clouds of gas, all the way to their final farewell. Deep in the Orion Nebula, Hubble even saw the breeding ground of new solar systems. Dusty disks around newborn stars that may soon condense into planets. The Space Telescope studied thousands of individual stars in giant globular clusters, the oldest stellar families in the universe. And galaxies, of course. Never before had astronomers seen so much detail. Majestic spirals, absorbing dust lanes, violent collisions. Extremely long exposures of blank regions of sky even revealed thousands of faint galaxies billions of light years away. Photons that were emitted when the universe was still young. A window into the distant past, shedding new light on the ever-evolving cosmos.
Opening up the space frontier has been one of the most exciting developments in the history of the telescope. So what's next?
Cada vez maiores, mais precisos e aprimorados, os futuros telescópios deverão revelar as primeiras galáxias e estrelas existentes no universo.
In Arizona, the first mirror has been cast for the giant Magellan telescope. This huge instrument will be built at the Las Campanas Observatory in Chile. Its 7 mirrors, each well over 8 meters across, will be arranged like the petals of a flower. And together they will capture more than 4 times the amount of light any current telescope can catch. These future monsters, optimized for infrared observations, will all be outfitted with sensitive instruments and adaptive optics. They should reveal the very first generation of galaxies and stars in the history of the universe. Moreover, they may provide us with the first true picture of a planet in another solar system. Meet the James Webb Space Telescope, a space infrared observatory named after a former NASA administrator. Once in space, its 6.5-meter segmented mirror unfolds like a blooming flower, 7 times as sensitive as Hubble's. A large sunshade keeps the optics and the low-temperature instruments in permanent shadow, allowing them to operate near a whopping -233 degrees Celsius. The James Webb Space Telescope won't orbit the Earth. Instead, it will be parked 1.5 million kilometers from our planet, in a wide orbit around the Sun.
The universe is full of surprises. The sky never ceases to impress. No wonder that hundreds of thousands of amateur astronomers across the globe go out every clear night to marvel at the cosmos.
We've come a long way since Galileo began charting the heavens with his telescope 4 centuries ago. Today, we still observe the universe with telescopes, not only from Earth, but in the limitless regions of space. The seed of humanity lies in our seemingly endless supply of ingenuity and curiosity. We have just begun answering some of the greatest questions conceived. We have charted over 300 planets around other stars in our own Milky Way and located organic molecules on planets around far-flung stars. These incredible discoveries may seem like the zenith of human exploration, but the best is undoubtedly yet to come. You too can join the discoverers. Look up and wonder.
Como vimos ao longo do programa, não tem sido por falta de esforço e criatividade que ainda existem muitos segredos a serem desvendados sobre o universo. Tentem imaginar a diferença entre Galileu, com seu modesto telescópio feito em casa, e as poderosas máquinas que o homem utiliza hoje para investigar o espaço. Ainda assim, apesar de todo o progresso, existem mais dúvidas do que certezas sobre a origem dos planetas, das estrelas e do próprio homem. Esta edição do Matéria de Capa fica por aqui. Voltamos no próximo domingo às 7 da noite. Uma boa noite a todos e até lá.